Looking at number 1. So before we even start with these questions and reviewing our questions, what is our rule for the law of zero exponents? So when we have an exponent of 0, what does our law of exponents tell us that we have to do, Marquavius?
It'll always be 1.
Will it always be 1?
Well, no, with the exception.
Alright, when will it not be 1? D'Amico?
0.
When you have a 0, and when you have 0 to the 0 power, that is what? 0 to the 0 power is what? Undefined. So we need to make sure that we understand that our rule for the law of exponents for 0 exponents is any non-zero number, the answer is going, that has an exponent of 0, your answer is going to be 1. Alright, what about our rule for negative exponents? So according to the law of exponents, when we're referring to negative exponents, what does our rule tell us that we have to do? AJ?
Use the reciprocal.
You use the reciprocal. So we're going to be flipping. So for any non-zero number and any non-zero base, we're going to be flipping. We're going to be using the reciprocal. So it's important for us to understand what a reciprocal is. All right. Another thing, when we're talking about negative exponents, what happens to our exponent? So we say we flip it, we use the reciprocal, but what else happens to our exponent? Let's say our exponent started off as a -2. What happens to our exponent, Antonio?
Positive.
It becomes a positive. So basically we're using it's a negative reciprocal. So it's going to be the opposite of whatever it started out as. Alright, so looking at the first one, we have 3n to the -2nd power. So do we have any exponent attached to the 3? Do we have any exponent attached to the base of 3?
No.
No. So are we doing anything with the 3?
No.
No, the 3 stays the same. Is there an exponent attached to the base of n?
Yes.
Yes. What's attached to it?
-2.
-2. So what does that exponent of -2 tell us we have to do?
Turn it into a positive.
Turn it into a positive. And what else? Use the reciprocal. So we know our 3 is staying the same. What operation is taking place between the 3 and the n?
Multiplication.
So still multiplication. And now when we flip this, when we use the reciprocal, what does n -2 become? N to the -2nd power becomes what?
1 over negative, n times -2.
What does our reciprocal? That is not, we need to get the correct terminology. Not n times 2, because it's not n times 2. What is the correct reciprocal to n to the -2nd power? Marquavius.
N to the 2nd power.
Alright, now I need you to give me the whole, because that's not what we're working with. Rachel. 1 over n to the 2nd power. That is correct. So now what do we need to do? Catherine. Make it into a fraction. So we need to multiply our fraction. Multiply straight. 3 times 1 is what? 1 times n squared is what?
N squared.
So our final answer is 3n squared. This is not a difficult concept. We have to make sure that we take, I think a lot of us are getting confused and we're distributing this -2 to our all numbers on the inside. We only distribute if this is in parentheses, because that means that everything on the inside is distributed by that outside exponent. If there's no parentheses, this exponent is attached to the base that's directly next to it. So we need to make sure we get that. We understand that. Alright, so number 2, who did number 2? Alright, what did you do? Tell me what you did.
Since it started out as 1 over n -3, I just flipped it around to make the -3. I mean, not the -3. The square cube -3. I made it a positive, and so I got n cubed over 1.
Alright, do we have to have that 1 there? No, so n cubed over 1 is correct, or we could just have this as n cubed. That is it. Once again, all we're doing is using a reciprocal. So if we have a fraction of 1/4, what is the reciprocal to 1/4? What is the reciprocal to 1/4? Jordan? Just 4. So we have to make sure that we understand that all we're